taking this part, there's a question, no? So let me go for diagram showing all things clearly. So what about the forces that are liquid air, which is present on the top, will exert a force. The liquid which is present beside will exert a force like this. And what about the liquid? The liquid which is present here, here it will exert force here, no? Because what is the property of liquid? On what all surfaces it comes in contact, it will exert a force. Will agree? Okay, now let's analyze how to calculate the force on the curved surface. Okay, let this force, the resultant force exerted on the surface 2, let it be, this is F2. Let this force be F1. Let this be F2. Can we, what is asking? The question is asked F1, no? So what is the basic definition? Or is how you define by upward thrust? Net force exerted by the liquid on the solid. So we'll go for basic definition of buoyant force. So what is the definition of buoyant force says? FB is equal to, I'll write, I think I'll start it here. Buoyant force should be equal to what? F1 minus F2. Do we know buoyant force? What is the buoyant force density of liquid? Volume immersed into G. So what is F1? F1 is what we have to find out. What is F2? F2 will be area, this will be of radius R. F2 will be pressure into P2 into area. Let's come for volume immersed. What is the volume immersed? Volume of cylinder, pi R square into 3R. Volume of cylinder. In that, I'll remove hemisphere. What is the volume of hemisphere? 2 by 3 pi R cube into G equal to F1. P2 is what? P2 will be rho L G 2R pi R square. So solving all this, we'll get the required expression. Rho L, this will be 3, 9, 9 minus 2, 7, 7 pi R cube by 3G. So this will be 2 rho L pi R cube G. So what is the total force will be? Rho L pi R cube G, 7 by 3 plus 2. 3 2 just 6, 6, 6 plus 7, 13, 13 by 3. So this will be 13 pi rho L R cube G by 3. Okay, this is the force exerted by the liquid on the curved surface. Just that's the concept of what? The buoyancy. I'm showing the total question. Fine. So now here of thoughts, not only this, any object. So if you know what force is acting here, if you know this force, and you know buoyant force, so you can calculate the force exerted by the liquid on the bottom. And what is the buoyant force? Buoyant force is equal to rho L Vg. I think there's a one super idea, no? Otherwise, what you should do, you should go for the hydrostatic method. Assume a ring, then on that small strip, what is the force acting? There's the method. I think this will be much easier, no? Sir, why it should be upward? You see, like a horizontal force will cancel